Hello and welcome to the Oxford MAT Livestream. My name's James and I'm joined today by all of you lovely people in Slido chat. If you want to join the chat and you're watching live, we're over in slido.com/MATLIVE. You know the drill by now. Also Flora, who's here helping moderate chat. You know Flora from previous MAT live streams. Hi to username Phi, hi George. Oh, I haven't turned on replies, thank you. Person who spotted that, I always forget. And there we go, good. You should now be able to reply to each other if you want to talk about maths. Hi to Fihan and Becca, and X+IY, he was here while we were warming up. Hi to anonymous people. If you're joining for the first time, great to have you with us. We're going to do some maths. You can be anonymous in the chat if you like. If you're watching the replay, then great to have you with us. Also, okay, it's the day before, the day we're recording this, it's the day before the UCAS deadline. Hopefully, if you're applying to Oxford this year, you've made your application already. I've been getting quite a lot of phone calls today. Hello, if you're one of the people who's phoned me today. Also, hi Zach, Anonymous, Alex and Raf and Ali. Ali noticed the new colour scheme in the Slido, which has always been there. I had a weird experience with a phone earlier. I phoned someone and while I was leaving a message, I went to their answer phone, and while I was leaving them a message, my phone completely broke. All of the buttons went away, including the one that ends the call. So someone out there has got a voicemail from me where I do my normal professional talking, and then there's a pause at the end while I try and end the call with no buttons on my phone and try and work out how I reset my phone, fumbling around, trying to not swear or say anything I shouldn't or divide by 0 while I try and work out how to hang up the call. And all of that's been recorded, and one of you has that as a voicemail. So sorry if that was you. Okay, cool. How's your day going, everyone? I can't use phones. People's days so far, people are voting in a Slido poll. We're going to be using quite a lot of Slido polls today. Because the plan today is we're going to look at the 2018 paper, which I've got in some zoomed out version here. This is MAT 2018. Let's write that, MAT. That has not worked. That's not worked at all. There we go, MAT 2018. That's tiny writing, I can't see that at all. We're going to use a Slido poll to decide which questions we're going to talk about live. We're going to use a Slido poll to decide which questions to watch live. Last year I made a whole video going through every single question. So if we don't cover the question that you want to cover, there is a pre-recorded video of me talking about every single question. We did two versions. We did a 10-minute version and we've got a 2-hour version. I'll link to the 2-hour version at some point on the live stream page, so you can watch it. Instead of solutions doc, you can watch the long solutions video, but I want to talk about some of them live to talk to you about live questions. If you've done the 2018 paper already, then that's great. We can talk about what you did and how it went. If you haven't, then hey, these 3 live streams at the end are going to be a little bit more useful if you've had a look at the questions in advance. I might skip bits of them, and I might skip reading them out to be faster. Okay, people's days are going at a solid 4.1, which is actually quite good for us. As always, I'm looking out for the people who 6% of people who put 1 or 2. I hope your day gets better. My day is a solid 3. Somebody did ask, which is very nice of them. My day, I put it a solid 3 because of all the calls about how to do a UCAS application. And that one person I called who has got a very confusing answer phone message for me. Someone says, how much time left before the deadline? Flora's answered, tomorrow is the deadline. The deadline is technically 6 p.m. UK time. On the 15th of October. It's the 15th of October every year at 6 p.m. UK time. Hello. Right, okay, good. Maybe people liked the 2018 paper. Who knows? Who knows? I don't actually have a poll for that. Okay, so here's how this works. Hang on, let's just catch up with chat quickly. Did I miss anything? Are we going to do, MX wants to know, are we going to do all the question? Probably not all of the questions. We'll catch up with some of them. Okay. Right, cool. Okay. Here's how it works. There's going to be a Slido poll. The Slido poll has lots of options. The Slido poll has options for every question. You can vote for multiple things, and in between questions, I'll turn the voter back on again. So you can't see this if you're watching the replay. This has got an option for every question, and the people watching live are currently voting. Oh, look at it go on which questions they would like to tackle. I'll let that go for a bit while people catch up. I'm just going to have a quick look at the questions on screen in case you've forgotten which one's which. There's some integrations, some e to the kx, we've got some parabolas, we've got some translations of graphs, we've got some circles, some vectors moving around, we've got some parabolas that just touch, we've got some points inside a circle, some which of these sketches question, and a thing here for which one of these shapes could be this curve. For a moment there, I got distracted. For a moment there, about 5 or 6 questions were drawing at 37%, which is such a weird percentage. Oh, amazing. Cool. How's chat going? Chat is currently hidden behind this, so you can't see it. Okay, question 2 was about this one with these transformations of the plane. 3, another question for mathematicians, has these parabolas glued together, and the question is mostly talking about, is this a cubic or not? How are they drawing? How are they drawing so perfectly? 53%, what's going on there? I don't understand. How have those questions got exactly the same number of votes? Neck and neck, I'm very excited. Question 4 has this diagram in. Look at this diagram, which has a whole lot going on in that diagram. 5 is about stacking together towers, and it has, maybe this is flashbacks, it has some recursion, which we talked about last week. 6 has some Egyptian fractions, or these are called friendly form, or Egyptian fractions. And question 7 has this person moving through a grid to pick up coins. Okay, and in chat behind, someone's noticed that I said in the YouTube description, I think I said last week, that one of these questions was the first question I ever designed. Which one was it? Yeah, Tippy wants to know. And also simultaneously, someone says, I love question 1b because it makes me feel smart despite being very easy compared to everything else. It's just, I think my poll, I'm going to pause the poll, I think, just to highlight this amazing comment. That's how you're supposed to feel when you do question 1v. Hi chat, question 1v is mine. This is my math question, I wrote that one. Brilliant. I'm glad it made at least one person feel smart. Good, right, okay. But it hasn't won the vote, so we're not going to talk about it. We're going to talk about what actually won. Question 2 won, very close, but question 2 won. So we're going to talk about question 2, and then I'll do the vote again. When we do the vote again after talking about question 2, I'll leave question 2 in case people want to talk about it again. But I think it comes back and you can change your votes or read down. Okay, right, how are we doing? Good. Okay, I've got chat open. 1H was way up there. I reckon we'll do 1H next, probably. It's nice, isn't it? I like the way that people can see other people having trouble with the same stuff. And question 2, I guess, because everyone has to look at it, and it is quite a tricky question. And then 1H as well, which is a bit tricky. Cool, okay. I'm going to do Tom's question now as well, while it's here, before I forget about it. Do I know of topics beyond A-level that may be helpful for math? No. Topics beyond A-level are not supposed to be helpful for math. We write it very carefully, hoping that topics beyond A-level, if you've seen them, don't help you with the math, because we want it to be fair for people who have just seen A-level. Good. A lot of people use differentiation at GCSE. Ooh, I don't know about that. Does differentiation make GCSE easy? Let me know in chat. Cool. Is it a secret fluid dynamics question? We're not talking about 1b. We're not talking about 1b, we're talking about question 2. Right, cool. Okay, and I'm going to try and go a little bit quickly. He says, having used 9 minutes just on rambling at the start, talking about phones. Okay, I think this first part is easy, hopefully happy smiley faced, right? We're asked to show that when you apply these operations, so this is the composition, to do one thing and then another thing, that the order matters. It's not the same thing to apply this transformation and then that one versus that one and then this one. And you can just check that by checking what happens to x and y as we put something in. Okay. So maybe we just check that, and I think I'm not going to do the algebra now. Part 2 is, I think, also smiley face, but maybe I will do the algebra for this one. So here we've got t to the n to mean do t n times. So maybe we work out what t squared of xy is. So t squared of xy means do t to the thing that happens after you've already done t, which means do t to minus yx. What does t actually mean? It means switch the inputs around and put a minus sign in front of this one. So if I do that for this, then I get minus x minus y. It's a little bit abstract, isn't it? It's a little bit tricky to flip things around like this and to say, well, here the inputs are X and Y, and they go here and here. But now the inputs are these letters. And okay, those are the same letters of the alphabet, but the kind of shape of what I do is the same. We talked about this a little bit a while back when there was a function with a subscript and an input, and we thought about how the subscript and the input were telling you where to put in the inputs for the function. Okay. If your school is doing Welsh board for further maths, that sounds like it makes no difference. Matt has got no further maths on it, so you should be okay. Okay. Cool, so Tsquared does this thing. Now, Tsquared flips around, takes xy input, and it gives you back minus x minus y. That's pretty interesting. Let's check what T cubes does. So if we apply T 3 times, then that means apply T one more time to this. That's going to be, so this says switch the inputs around and put a minus sign in front of the first one that you get. So that's this. Okay, so I'm not back to where I started yet, but if I do one more, then I will get back to where I started. So switch them around, put a minus sign in the front. Brilliant, okay. So n equals 4 is one example. And there are some more, because if I do this 4 more times, then I get back to xy as well. And if I was writing this out in the lovely gap down here, all this space, and the next page more space, then I would explain that after applying it 4 times I get back to where I started, so any multiple of 4 does the same thing because it's applying this operation 4 times, some number of times. I've probably used some letters, some algebra to explain that a little bit, to say, right, if n equals 4m, then, and I would say, aha, you've applied t to the 4 m times, which means you've done the identity, you've done no change, m times. Okay, a little bit of explaining there. Cool. Someone says, is t, it's Pehan, says, is t a reflection in the line y equals minus x? Good question. The answer is no, but close, almost. There's a sort of geometry way to do this. When we were writing this question, the person who wrote it was thinking in terms of geometry, and then I tried the question to check how hard it was, and I thought about it entirely in terms of algebra. So we had a meeting, and the person who said it said, "Oh, did you notice that it's geometry? You've done this entirely with algebra." And I thought, "Oh, I hadn't noticed it was geometry at all." But there's some sort of geometric thing that's going on. This one's a bit like a translation, right? And this one is something else. Okay. Someone's applied to Cambridge in computer science, and they say they're terrified. Oh, don't be terrified. Cambridge is nice. People say good luck. Flora says, well done for having a go. Yeah, let's go. You do not need to do the math for Cambridge Computer Science, but nice to have you with us anyway. Trying some maths questions. Right, okay. What am I doing? I think I'm doing part 3. Okay. So, part 3, and I've had a request in here to use some of the sessions we've had left to cover the way in which we write out our solution with some examples, if possible. If I write, okay, there's some good questions coming in as well. So maybe I'll do part 3 properly, and I'll write out my answer as well. I'll be a little bit slower, but I'll give it a go. Okay. So my idea for making U is that I saw on the way through doing this Tsquared thing, you get some minus signs in there. I want to try and use those minus signs to end up doing a shift. You see, I've got S which adds 1. I've got S which adds 1. My kind of plan is to add 1 and then flip it again so that that becomes a minus 1. I think it's my plan to use Tsquared like that. People have got more guesses. Someone says, isn't it a matrix? And I suppose, sure, if you know about matrices, then you can rewrite this question using matrices. It doesn't get harder or easier, I think. It's just now it uses matrices, which I think a lot of people find harder than functions. But hey, okay, if you want to use matrices, go for it. But you don't need to know about matrices. Someone says, is it a rotation? And I think it is a rotation. Noticing that this is a rotation might actually be a nice idea, so that if you start at the point, if x is 1 and y is 2, then you go to minus 2, 1. Minus 2, 1 is over here. It's been rotated by 90 degrees clockwise. Yes. Who said that? It was a rotation. Aha! It's been rotated by 90 degrees. Good observation. Cool. As I was saying, you can do this question without noticing that. I've been thinking about algebra here, so I think t squared of xy is equal to minus x minus y, and then st squared of xy. So if you now do s, then that adds 1. So this is my cunning plan, right? That I'm gonna put the minus signs in using t squared, so I get a minus x over here, and I'm gonna add 1. I can see that that's gonna be x minus 1, but flipped, because I'm gonna do t squared again. This is a little bit like a question about building blocks, where once you've worked out these things, you're allowed to use them later on in the question. Oh right, okay. Someone says they've been ill recently. Sorry to hear that, of course. Just done with the syllabus mentioned on the website. Great, you've learnt the maths that you need to know for MAT. Best strategy so I can get 90 to 100. Didn't practice a single MAT paper. Here we are now. Here's a MAT paper. Let's go. I think it's probably the right place to be. I hope you're feeling better. I don't know. Goodness me, I hope you're recovering. We're going to do some maths. Feels like a good idea to me. Yes, good. Right, okay. So I've built this map U. Oh no, I haven't. I've got my 1s and minus x's wrong. People in chat are going to tell me that in about 20 seconds. Yes, thank you, Zizo. You win. Yeah, you win. It's x minus 1, not 1 minus x. Which is also what I wanted. It was what I was trying to write. But you win. Okay, cool. So I've built U. I used 5. Okay, so this series of operations. So I'm going to write a little conclusion. So some order of s and t squared s t squared can produce u. Okay, cool. So this is the first part. I've done a show that, and I've shown it by sort of explicitly doing it, which is something you're allowed to do, I guess. What is the least number of applications of s and t in total that can produce u? Okay, so I feel like it's 5 because I feel like I'm great and efficient, and I've done it in 5. So I'm going to try and say, well, I'm going to see if I can prove that. I'm going to say maybe 4 is impossible, 3, 2, 1 impossible. Also, I think not just using 5, but I think you want this as the sort of minimal example. Maybe I'm just too confident that I've already found the thing that's the fewest number of applications that produces u. But I'm going to give it a go first, right? Maybe along the way I'll find something that uses fewer. Okay, so I really want that t. So I guess I'm going to start writing it. I'm that confident. Can't have fewer than 5 operations. You must have t. No, you must have an s in there, not just t. By part 2, because we saw in part 2 that just using t produces these transformations, which I don't want. They're not u. And then I'm going to say must have 4 copies, or I'm going to put in at least, of s, so that coefficient, I'm going to say, so the thing that changes when you apply, I've got s and t the wrong way around again, 4 copies of t, so that the thing that changes, I'm going to say, is the coefficient. So after you've done t twice, you get the coefficient of x here as a minus sign. Then you do it twice more. You need to do it twice more to get back to having a coefficient of 1. So coefficient of x in, let's be really precise, first component of x in the first component is 1. I suppose that's also by part 2 that we looked at what happens when you apply t lots. But also I'm thinking a little bit about what happens in general if you apply lots of S and T, I'm going to write something like, what do I want? So a big general thing would be sort of T of, if I have something complicated like this, so if I put some letters in to show what I'm talking about, let's put some Y's in there. Ah, I've got too many letters now, haven't I? What are people saying in here? No step that's redundant, something about rotating. People want to talk about rotating 4 times? Yeah, people want to talk about rotatings. Oh, and you can leave your rough work in. Somebody asked that a moment ago. Yeah, I would encourage you to leave some rough work in there, because questions like this sometimes have marks for working out. This thing I'm about to write down is not quite enough, I suppose. Because I haven't got there's some numbers in there as well, aren't there? As well as coefficients of x and y. I kind of want plus e plus f inside. I might, if I was doing this for real, rewrite this a little bit more neatly, but only if I had time. Okay, so here I'm going to say that the coefficient, what am I saying? I think I'm saying that coefficient switches each time you do a t. Do I want these a's and b's? I don't think I do. No, I don't agree with this at all anymore. I'm going to say t of. Oh, maybe I do. I think I'm going to leave it like that and move on. See if that's good enough to convince people. What do I mean more neatly? Well, it was getting quite messy because I was writing on different lines and I've got these like bits where it doesn't quite fit inside the brackets. Mostly that's a mess because I'm writing on this online whiteboard thing. Yeah. Okay, cool. I think we've got the right idea. We're talking about this coefficient of x. Some people are talking about rotating the plane and how you've got to rotate by 90 degrees 4 times, at least 4 times, to get back to where you started so that points far away are rotated back to the right place, I guess. Yeah, you could rule out some optional step minus y. Cool, okay. I love this. What do you mean more neatly? Okay. I don't know. I think this was getting quite messy, and then I changed my mind about writing all of it. Okay, cool. That was fun. Part 4. Okay. So we're doing quite well now. We've got a map S, and I'm going to try and use the previous one. I love using the previous part, right? We've done loads of work to show that you can combine S and T together to make this map U that moves to the left instead of moving to the right. Okay. So, and this question is now asking about some sequence, not the smallest, shortest sequence possible. How much do markers? Oh, right. Okay. So, how much do markers care about work being ordered and easy to read? Not that much. We'll try to read what you wrote. If we can read it, we'll mark it. If it's worth the marks, we'll give you the marks. The markers are prepared to do quite a bit of work to find out what you mean. And there's no threshold mark. There's no threshold because the more marks you get, the better. Cool. Do I have an answer paper for math? Yes, I do. Cool. Okay. Good chat. Let's talk about part 4. Okay. So I think I can get to. Let's do some sort of. If b equals 0, then we can just use S and U. S is the one that moves to the right. I guess S or U would be enough to get to the point, to move 0, 0 to the point A, B, if B is 0, because that just changes the number in the first component. Okay, these are vectors, right? They've got two components. I can talk about the components. Matt's on the 3rd of November 2021, Zach, which is about 3 weeks away, I guess. Okay. If b is not 0, then we'll need to do some moving up and down. How are we going to move up and down? Let's have suggestions in chat for how do I get the point 0, 0. So I can see how if I plug 0, 0 in here, I get 1, 0. It's good, that's moving left, right. If I plug 0, 0 in here, then I get 0, 0, which, well, that's still the origin. How am I going to get to 0, 1? So for any integers a and b, How am I going to get to 0, 1? Some combination of maps. Yeah, here's a suggestion from Anonymous, and I can see that x plus iy has put something in as well. We're going to try and find a different combination of s and t's to move up and down. If we can move up and down, then we're done, because we've got one combination of transformations that moves us left, right, and a different combination of transformations that moves us up and down. I think x plus iy suggests that STS works for that. What do I think about that? So s first takes us to x plus 1 y. X plus 1 y, and then do a t. So I wonder how they came up with this one. But yeah, I think I agree. Well, maybe I agree. I'm not sure I want this extra s on the end. I quite like this. This TS combination seems quite nice because it takes you to a place where you've now added 1 to the second component, which is pretty good. Maybe I just want TS. Should be pretty good. Loki, hi Loki, says do S then do T. Yeah, I think I'm agreeing with this. Here we go. Do S then do T, and it moves you to so that you get some transformation that has X and Y in it. But if you put in 0, 0, then you go to 0, 1. What do other people say? Oh, chat's going quite fast today. We got more people than normal? No, we've got fewer people than normal. But more chat, which is nice. More people joining in. Look at this. Use the same 5 functions as in question 3. Okay. You can reposition where you execute the function s. Ooh. Control the direction you move in. So I can't change the function s. The function s is at the top there. It is what it is. Yeah, I see what you mean though. You want to... Oh, you change where in the order you do the s. I think that maybe that's what you mean. Change where in the sequence you do the s. I think that's good. I think that works. So if you take this sequence down here, which shifted left, and you move the s to be in a different place in that sequence, then you end up with a translation in a different direction. I think that works actually. That's good. Hopefully everyone agrees that we're looking for these transformations. I think people in chat have found them to do the transformations in different directions. Did somebody want to do? I think somebody wanted to do t cubed. This is all nonsense. I don't know why I wrote all that. What do I want? Oh goodness me. There we go. Let's write something true on the board. There we go. S then t does this. So maybe if you do t cubed first, then it flips the minus sign, fixes the minus sign here. Anyway, good. Okay. And S then 3 t's to get what you want. Oh, okay. So we'll do 2 more t's. Goodness me. I want to do maybe 3 or 4 t's, I suppose, and then I might get round to where I started again. Might get around. Okay, cool. So some combination of t's and s's, maybe with 1 s and 4 t's in some order, gives you these transformations that move in different directions. That's all that the question wants you to do, really, because then if you do some of those in combination, you can set up a transformation that moves 0, 0 to AB by doing A translations in one direction, B translations in the other direction. Okay, so it's not too bad. Raf agrees, brilliant. TTTST, which means do T then S then 3 T's, which I think people in chat have been telling me, but I've been not writing on the board because I'm scared I'm going to make a mess of it, like I did over here. Okay, cool, good. Yeah, and I can see that over there now. Good, okay. Somebody wants any potential leaks for this year's paper, and then 3 emojis and 3 question marks, which is very polite, isn't it? Okay, cool, good. I like the people suggesting stuff for making these transformations. More in the official solution doc, I guess, but I think we've had the right ideas. Part 5, super hard. Part 5 wants to know what happens to the equation of the curve when you apply transformation to a whole set of points that make up this parabola. So this means take the points that make up the parabola, apply the transformation to all of them, and now find a new equation for that new shape. I mean, it's probably a parabola because you translated it or rotated it, but find a new equation for that. It's actually quite tricky. It's almost the opposite of what you might guess. It's one of those things where I think probably 50% of people doing this question are going to write down the opposite of the thing that I'm about to do, and that's really annoying. But there's not much we can do about that other than just be 50% of people with minor signs. Somebody wants suggestions for a course of action based on my experience with the MAT, for people who have just found out about the MAT and want some sort of experience for practicing MAT questions. We've made a MAT live stream, and maybe more seriously, we've made a bunch of resources for it. So if you go to the MAT live stream page, which is linked at the bottom there, you can look back at a series of revision exercises, warm-up problems, past MAT questions with hints, and now actual past papers as well. Great to have you with us. We've been doing this for a while. You can catch up with that stuff if you want to, or you can join us live to talk about which is what you're doing. Okay, cool. Right, part 5, here we go. Okay, let's talk about the parabola. We're going to do the first one, and then the other one is what I'm going to leave. The parabola is these points. Okay, it's got that equation. So that means that the points have, well, they have y equals this. So the points on the parabola are like this. It's kind of that for all x, that for any value of x you have these points are on the parabola. They've got this x coordinate, x, and they've got this y coordinate, x squared plus 2x plus 2. And then s of that point, this is going to really annoy 50% of people, I'm sorry, is this. S takes that point and translates it, well, changes the first component by adding 1 over here. So that means we end up in a new world where the point is now somewhere, it's being moved somewhere. And we've got to work out a new equation for this curve. We're asked for an equation for this, which is pretty rough, because I want to use the letters x and y really for my equation, because I'm used to writing writing equations of curves down in terms of x and y. But x and y, I'm sort of already using the letter x, so this is a little bit annoying. I almost wish that I'd used a different letter, right, for where the points are, because this x in here is just describing, it says for all x, so it's just describing all of the points on the curve. Out here, this is a bit annoying, because now the letter x is annoyingly this thing in here, the kind of x coordinate of where I am, involves the letter x, but it's not x. I'm actually going to rewrite this. So this is my first idea. I'm actually going to rewrite this. I'm going to write, instead we could write the points on the curve as, we could use any letter we like, right? A squared plus 2a plus 2 for all a, or you could use your favourite letter of the alphabet or symbol or whatever. And then s of those points, s doesn't really care what letter of the alphabet you use, s just adds 1 over here. And now it's a little bit easier to talk about the equation, because now I can use x and y. I've saved those letters for talking about the equation. Here I've got x, my x coordinate is a plus 1, and my y component is a squared plus 2a plus 2. That I can see, if I want to write this in terms of x, then I need to write this thing in terms of a plus 1. It's this. Okay. So, did they really have to make that question like that? So this is a kind of hack where I realised while I was doing my algebra that I wanted to use the letters x and y here, but I'd already wasted the letter x, so I kind of redid it. Maybe in an exam I might squiggle over them or might rewrite it, because I realised that near the end I wanted to use the letters x and y. Now some people are happy at this stage writing this equation for the line in terms of completely new letters. Just keep bringing in new letters. I think if you look at the official solution on the web, on the MAT page, they bring in the letters u and v and start talking about the equation of this curve in terms of u and v, and then secretly switch them to being x and y to talk about the equation, which is a bit of a strange thing to do. But its kind of alternative is, go back and just use a different letter for describing where the original points are. I prefer that because now I can talk about my final answer in terms of x and y like this. Okay. Oh my word. Okay, so S and T The question refers to S&T as functions that translate the xy plane instead of the graph. So doesn't the parabola move in the opposite direction? I think that's a really great way to have an extra minus sign in there. That's a really interesting way to look at it. I think the transformations act on the points in the graph, and I think the parabola is made of points in the xy plane. So I think the transformation applies to the points rather than applying to the grid paper beneath the points. Okay, right. I think the plane's made of points, not made of graph paper, if that makes sense. Right, okay, good. Okay. Cool. I'm not sure if I spelt out my alternative well enough, but, you know, over here I could have been like, aha, I will call this u, and I will call this v, and I will write down v is equal to u squared plus 1, and then I will say that that equation is y equals x squared plus 1. And that kind of looks weird, because I brought in these letters u and v up here. Cool, okay. This part's hard. I reckon about 50% of people who tried this question will have moved it in the opposite direction. Written this thing instead of the other thing. It's like that thing about plus and minus signs in translations, except this has got an extra level of weird going on. Okay, that's question 2. Overall, bit of transformations, bit of thinking about what happens when you apply lots of functions lots of times. I think this question was quite hard. I think it had some bits at the start where you can pick up some marks. You're allowed to do that, of course, pick up some marks and then stop. Maybe some points later on where you could try and pick up some marks by just, if you don't like part 2, skip part 2, talk about part 3, and how to build u. Maybe you can find a way to build u, whether or not you can say that that's the least number. Okay. Oh, I often write quite big. Am I allowed to ask for spare paper? Asks someone in chat. There's lots of space in the question booklet. You're officially not supposed to use spare paper because there isn't an official way to have spare paper in the exam room or attach it to your script. In the past, if people have used spare paper, I don't know where they got the spare paper from, but if people have used spare paper and attached it to the script and it's made it to us and got scanned in, then we mark it. If we get it and we can read it, then we'll mark it. But you are strongly encouraged to write in the question booklet, please, especially this year because we're scanning lots of things. Cool. Okay. The big question. Someone's asked basically the same question at basically the same time. Right. Cool. Let's do the poll again. I think I'm done talking about question 2. Oh, it's quite a lot of time. Oh, there are the votes again. If you voted before, your vote is still there. Maybe I do need to delete question 2 from this. I'm going to delete. Here we go. I'm going to question 2 delete. Save. Oh, there we go. Oh, okay. Right. Cool. How are things drawing? I don't understand how things can draw in this poll. Is that everyone voting for them? Or 53, James? 53%. Looks like 1H is doing quite well. Oh yeah, 1H is pretty tricky. A side effect of doing the live stream like this, by the way, is that we're I'm going to leave that vote going for a little bit. A side effect of doing it like this is that we're only talking about the hardest bits of the paper and the bits that you found the hardest, like by design. That's what we're voting on. Probably there are some bits of this question paper, if you tried it, that weren't so bad, that you just did, and we're not talking about them because they were fine. Try to remember that. We had this quite a bit last year with the MAT Livestream, that we're really focusing on things that you find very difficult, and then of course there's other stuff that you didn't find so difficult that we're not talking about. Please don't forget about it. Cool. Yeah, people voting multiple times. Okay. People want to talk to Georgie from last week. If you contact us, and we can try and talk to computer scientists for you as well. Georgie was on last week to talk about recursion. Georgie's very busy. I can try and find friendly computer scientists to answer questions if you want to. Somebody found question 1H to be the nicest question. Is that weird? 51% of people might agree that it is a little bit different to their opinion. Okay. Zizzo, it's fine to answer your questions at the end. Yeah, it says that on the front of the paper and everything. Okay, looks like people are voting for question 1H, so we'll have a look at that one. And it's on the screen, so why not? Multiple choice question. Oh, okay. I think this question's tough and possibly a little bit mean because it brings in these triangles and this circle, but it's not really about triangles and circles. as shown in the diagram below. It's not really about triangles and circles at all. The triangles of these areas, S and T, so there's triangle S over here, and there's triangle T over here with area T. And S is the smaller triangle, so S is smaller than T. We're asked for the smallest value of this function, which I'm not going to worry about right now. Because when you see something like this, it's quite a strange setup. We're not told where, we're not told how big the circle is, we're not told where the circle is, we're not told where are the points, we're not really told anything. So there's sort of quite a lot of possibilities, right? If we're varying, if we're thinking about, you know, what S and T could be, then I suppose we could, just looking at this picture, we could move the points around. There are other cases, right? S could be different. Please, Dr. James, can you get some computer scientists to talk to us? I did that last week. They were fun. They helped. We can try. Computer science also have their own email address, so you could contact the computer science department. This is the maths department. Cool. Okay, they are quite friendly. You can talk to them. Good. Okay. Somebody in chat has said that it's a cyclic quadrilateral, which I think is why this question's hard, because that's true. It's a cyclic quadrilateral. That fact doesn't help us at all. Sorry. It just turns out that, yeah, it's a cyclic quadrilateral. We can put some angles in if you like, but we can start writing down the areas of these triangles. But I could write down these areas of triangles in terms of things I don't know. I don't know any of the lengths. I don't know any of the angles. I guess I know the angles add up to 180 degrees. That's slightly nice, because sine of, if I call this theta and this is 180 minus theta, then sine of theta is equal to sine of 180 minus theta. So that's quite nice. It means that the areas of the triangles will involve 5 unknowns, not 6. But still, I don't really like this, right? So if I call these side lengths like this, then I get like half AB sine theta, and that's my t, and I get half CD sine theta over here as well. Aha! Using the fact the angles add up to 180 degrees. But so what, right? Like, I don't know A, but I don't know B, I don't know C, I don't know D. So there's this. Interesting. Cool. So there's this interesting idea that we could explore the massive possibility space of what's going on with the triangles S and T. So what's going on with these triangles? Are there different possibilities? I think someone's done a really creative rickroll that I'm just going to fall for very quickly. It's brilliant. It's really good. Oh, I love it. Okay, what a good rickroll. Okay, sorry. Okay, so thinking about different possibilities, we're not really told where these points are. So we can imagine moving the points around. That was great. You know who you are. That was really funny. Okay. That's been approved in chat, has it? Cool. Move the points around. I have slightly spoiled that by reacting to it before it got approved in chat. Maybe the fact it's been approved in chat is suspicious. Okay, we can move the points around. If I do that, then I can make S, the area S, very small indeed. Is it more funny or less funny knowing that for a good minute or two there I panicked, and you can rewind the video watch me panic. You can make S very small indeed. So S could be I think anything between 0 and T. Yeah, good. Okay. S can be anything between 0 and T, because we can make the triangle really small. We can't make it bigger than T because we're told it's smaller. That's the only thing we're told. But S can be anything between 0 and T. Okay, that means that S over T, I could write that like this. I guess, yeah, the ratio between them could be anything between 0 and 1. Okay, cool. I've written that ratio because this thing that I've been asked about looks like ratios to me. It looks like the ratio of different bits and pieces. People in chat really want to write this as 4 over 5 S over T plus 1 over 5 T over S. Let's go. So we'll split the fraction up into these things. And now it looks pretty good because we've got this relationship for the ratio of the sizes. We're told that S is smaller than T, and also that S is positive, I suppose, because it's an area. So the fractions work like this. The thing we're actually asked to, we're asked to find the smallest value of this stuff, which is, hang on, this question has nothing to do with triangles. We're asked to find the smallest value, forget all the triangles, smallest value of 4/5 Z plus 1/5 Z with Z somewhere between 0 and 1, right? S over T. Oh, 1/5, 1 over Z. Z somewhere between 0 and 1. Maybe S could be 0. And that's just some differentiation question, right? We've got some function, we'd like to find the smallest value of it. Z somewhere between 0 and 1, so think carefully about that. We should go and differentiate this and find the minimum. Huh. The S over T is X, and T over S is, you could call that 1 over X. Yeah, simplify the fraction. This is kind of super weird, that luckily the thing we're asked about just involves the ratio between S and T, like this. So it looks complicated because it looks like it involves S and T, but actually you can rewrite it to just use the ratio S over T. That's an important thing to spot because now it's a calculus question. So now we're asked to find the smallest value of this. That happens, maybe I should have used X. People prefer X, don't they? I'm going to switch it to an X. People love X. Yeah, let's call it X. That's what the kids like, right? Okay, so then we can differentiate it. When is that 0? X is, I guess, is that 1/2? And then the value is 4/5 times 1/2 plus 1/5 times 2, which is 4/5, I think. Is that one of the options? That's one of the options. Oh, is S allowed to be 0? Good question. I put the equal signs in because I wrote one by mistake. I think probably not. Doesn't really matter. Probably not, no. Yeah, no, I've changed my mind. I agree with Molly. Maybe I don't want... I agree with what Molly's implicitly thinking, I think. Maybe I don't want this to be 0. I'm a bit scared about S being 0 because it's being divided down here, and don't divide by 0. Okay. I'll fix it. It doesn't really matter because when you put in a small number close to 0, this thing gets really big, so sort of not how we're going to get the smallest value anyway. But maybe I agree, this thing should not be 0. The question sort of doesn't make sense if you let that be 0. Okay. Ali prefers U for substitutions, which is also what I do. Cool. Good. Okay, yeah. Avoiding that 0 in the denominator. Cool. And how did I get 1 over x squared? Oh, I'm differentiating. 1 over x. This was a 1 over x written really poorly. Let's tidy up a bit. This one's a 1 over x because it's t over s. T over s. T over s is 1 over s over t. So there's 1 over x here. So then I differentiated it. Sorry for the handwriting. Okay, cool. So this question's really hard, and then once you've spotted, oh, I see what they've done. The thing's not about triangles at all. It's not about cyclic quadrilaterals. It's not about geometry. S could be anything. We're just told that they're areas, so they're positive, and we're told that one's smaller than the other. Like even this fact, S being smaller than T, that's not a geometry fact. That's just something we're told. So we're just told that S is smaller than T. It's bigger than 0. That's all we know. It could be anything else. I suppose there's a tiny bit of geometry to realise that it could be anything else. Maybe the kind of perfect picture to draw might be to have a diameter in there. Have your area T over here. Choose the radius of the circle so that T is equal to the number T, and then choose the point round here so that the area S works out. So that for any numbers small s and small t, you can make this work. Cool. Right, yeah, that's a bit mad, wasn't it? Why have I solved x equals a half? Did I mess up? Yeah, I tried to solve an equation really quickly in my head. I rearranged this. When is this 0? I think it is 0 and 1/2. I think I did it quickly in my head correctly, which is a new thing for this live stream. Correct answers. I think it's 1/2. Yeah. Oh, is it sort of exam technique that maximising or minimising has maybe something to do with complete square round of differentiation? I think that's less exam technique, more you're really clever and you know some methods for minimising things. And you've got names for those methods, but I don't think that's exam technique. I think that's just you knowing how to do things, which is a completely different sort of stuff, right? Cool. Is it exam technique to know stuff? Like, I guess, but it's a pretty good exam technique, to be honest. Knowing things. Right, hang on, I'm deleting 1H from the poll. Cool. I'm also not talking about the questions very much, right? So we're looking at the hardest questions and I'm trying to do them quickly so that we can get through several. We're also not talking about them very much. Cool. Let's see what happens here. Okay, so I think question 5 is winning. I'm going to turn the lights on. Oh, it's a bit of a different live stream, isn't it? Normally I have a little bit of a plan about what I'm going to talk about and which questions we're going to do, right? And I've been doing these worksheets where I've carefully curated which questions to talk about, and I've written some hints and I've thought about them carefully, and I've got a plan before I go live. Here, it's just entirely at the mercy of whatever you want to vote for. Oh, I can see 1B coming up. Look at it go. It's beating 1F, which is better. People voting for 5, which makes sense, right? Because it's for all applicants. So if you're watching and you like computer science, then there you go, 1F. There's also something, question 5 is also something for you. Okay, let's have a look. What are we doing? How's chat going? We're going to keep going, by the way. I can see it's 10 to 6, but I'm going to keep going for maybe another half an hour or so after 6 o'clock. So if you're hanging around, then hang around and do some maths together. If you're going to watch the replay, then the replay will contain more maths. But yeah, going to run a little bit longer. Question 5 is 1, I think. Sort of the vote sort of hangs around from last time, but I kind of assume that, you know, I'm giving people a chance to change their mind about what we're doing. Okay. What's my plan here? I think I'd like to know which parts of the question people want to talk about the most. How about I'll do part 1 while you tell me in chat which parts you want to do. I'm not going to make a poll. I'm going to talk about part 1. So the question's a little bit tricky. You make these towers, you make these pictures by stacking things together. So they've got to fit exactly together. And you can split the number up any way you like. Exactly 2 other bricks. Yeah, okay, I know how to do this. Right, so a 4 tower. Above the 4, we need 2 towers that add up to 4. So we could have 1 and 3. Maybe I'll do that one first. 1 and 3. And then a 1 tower stacked above it. If it's a 1 tower, then we stop, don't we? A 1 brick. Yeah, the n tower is defined for n bigger than or equal to 2. So we stop when we put a 1 down. On top of the 3, we could have 1 and 2. I'm trying to be different to the one up there. And then above the 2, we've got to have 1 and 1. Because the only 2 tower starts with 2, puts 1 and 1 together. 1 and 1 makes 2. Welcome to the MAT Livestream. And cool, that looks nice to me. I'm going to try and draw the other ones better. Using zooming technology. Haha, there we go, zooming in. I thought of another one while I was going through, right? Or maybe not, maybe this is the same. This is the one in the question. I've messed up, chat. I've drawn the one in the question. Okay, worth exploring. I thought maybe I could do something different on the way up and then I ran out of options. People want to talk about part 3 and part 5? 1E, there's a sort of super vote for 1E. Somebody's put in chat that they want to talk about it. We can do 2, and do I have to use 2 bricks? I think I have to do 2, K1 and K2. So if I do a 2 here, then I've got to put 2 here as well. There's not many options for what you do on top of the 2, so this, or I could do 3 on the left. Now I'm relaxing a little bit, because when I've put 3 on the left, I've already thought about cases for what you put on top of the 3. You could do this, or you could do 2 and then 1. Hey, this is like the build leftwards one. Okay, so this one was the one in the question, already had it, but the other 4 are these ones. Okay, I quite like this one, it's very flat, isn't it? 1, 1, 1, 1, 2, 2, 4. Some good patterns there. Lena wants to talk about part 6. If I didn't do it yet, shall I go and do it myself? Maybe. I think I'm going to fast forward through some of these questions. So people wanted to talk about part 3 and part 5 on the last day stream. Let's do a Kahoot. I think the last day stream is actually the day after Matt, but sure. Next week is 2019, Tyler. Ah, yeah, Flora put that in chat as well. Yeah, we're doing 2018, 19, 20 now. That's a system. Okay, maximum height. So I think we made some really tall towers. This one's tall, this one's short. Felt like I could make a tall tower like this by taking my time to make things smaller. You know, don't rush, to go slowly through. So I feel like I can do this one. The maximum height, just make the numbers smaller, get away with as much as you can on the way up. Okay, we can justify that. Explain. I'm being systematic here, right? The area is the sum of the widths of the bricks. Ugh, okay. So the one of maximum height. Oh, that's not so bad. The one of maximum height is a nice shape. It is a nice shape, really. If you add a square at the bottom and a square at the top, then it's a triangle. We know about triangles. If not, then if you don't think of that, then you can think of adding together the numbers 2, 3, 4, 4. I guess we're asked about n towers. So this is going to be something like 2 plus 3 plus 4 plus n plus n. There's a bonus extra n for the brick at the bottom. Cool. Hey Molly, the name of the one after, the day after the Matt one is not Matt. We're avoiding Matt. There's a stream the day after the Matt where we're going to talk about anything other than the Matt. That's the idea. Did somebody say that they want to talk about the Matt? Yeah, okay, cool. Ooh, and George wrote that in terms of a sum. I is 2 to n plus a bonus extra n. Okay, maybe that catches people out, who knows. This is weird. Part 4 is really strange. I don't think anybody asked for it in chat, but if n is a power of 2, then we're okay. It's kind of a bit weird. If n's not a power of 2, then this isn't a whole number, so it can't be the height of a tower. So you sort of read it and you think, what? That's not the height of a tower. N was, no. You read it and it feels like it's not a power of 2, not a whole number, and then you realise, if n's a power of 2, then we're okay. This is at least a whole number. And now you're thinking about powers of 2. 4 is a power of 2, and we already drew this nice short picture, which turns out to be the right answer. This is like the right idea for part 4. The infinitely many is a sort of weird way, because there's only 1 for that value of n, but the question actually says infinitely many n. So it's asking you to say that there are lots of values of n. There are lots of powers of 2. Cool. Okay. Raf's hanging out until 5's done, because we're speed running it. Cool. We're on 5, which is the hard bit. Here we go. This is the recursion part of the question, isn't it? We're going to write Tn for the number of n towers. Okay. We have T1 is 1. Sure, you're right here. I'll draw a picture of it. 1. Good. And then we're looking for a formula for how many towers there are in terms of Tk for k less than n. So in terms of these previous values of T, in terms of the smaller towers. The way you do these is you think about how the big tower involves smaller towers. Said differently, Tn involves Tk, where k is smaller than n, because that's the number of small towers. Here's what I want. So Tn is number of n towers. That is an n brick, and then on top, what is this? This is going to be the key to getting a formula out of this that involves previous values of t. What do we put on top? We've got choices. Like all those recursion questions last week, we've got choices about what we do. We could have 1 and n minus 1, or we could have 2 and n minus 2, or there's lots of choices. Or we could have n minus 1 and 1. Okay, there's choices about how we do that bricks, how we split them up. Once we've done that, and we can keep doing cases, we can keep looking at the cases for splitting down what's going on top of those, but actually those problems, those sub-problems of what to build on top of those, that's the problem of making k towers for smaller values of k. And we've got to make a smaller tower on the left and a smaller tower on the right. Those are the sub-problems that kind of feel like the same problem but with smaller numbers because we've got smaller brick at the bottom. Okay, what do I actually want then? So I've got my choices. If I do, let's pick an interesting one. If I do this case where I've got a 2 here, and I've got an n-2 brick here, then my actual choices for how I finish the pattern are, I've got T2 choices for what to put on the left. Actually, T2 is only 1, but the number of 2 towers for what this thing on the left is. And this thing on the right is I've got Tn-2 choices for what to put on the right. Now I'm multiplying these together because I can make those choices independently. I've got my choices for what to put on the left of the tower and choices for what to put on top of the right of the tower. Those are T2 and Tn-2. Similarly, in this case, I've got T1 choices for what to put on the left with my 1 brick, and I've got Tn-1. That's how many choices I've got for this n-1 tower over here. I've got all of these separate things, all of these different choices about how I split up the brick. Once I split up the brick, I can use the numbers that I know how many towers there are for those choices in each case. So my final formula looks like this. It's Tn is equal to, I'm going to add all of these together because these are the different options. These ones are mutually exclusive. How am I going to split up that brick? They're mutually exclusive, so I'm adding them together. But inside each one, they're multiplied because I'm making those choices independently of how I build those towers. Once I've decided to split 3 and n-3, how do I build those towers? Okay. What's this last term? Tn-1, T1. Cool. I was going to draw a box around that, but I got distracted. Okay. Box. Cool. Nice. Right. Maybe let's rub out this bad box. Cool. Okay, I've got a nice formula. It's not that bad, really. It looks complicated because it's got lots of terms in, but it's describing how to build these towers using the rule about how towers work. Okay. Is that doing all right? Someone says, I'm doing the 2016 paper. Gonna go hear you explain the questions in a YouTube video. Yeah, cool. There are YouTube videos on this channel. If you click on this channel and scroll down a bit on the channel page, there's a playlist of 2016, 2017, 2018, 19. Yeah, those 4 have got 2-hour videos. It's like a whole movie of answers to math questions. Please don't watch the whole movie. There's way too much content. Like, it's got chapter points in it, so you can skip to the question you want to talk about. Question you want to see the answer to. There are also written solutions on the web as well. You don't have to watch the version with me in. Right, okay. Does somebody want part 6? Not really sure. Part 6 is to say it is not that bad once you've got the formula, because lots of these terms are repeated. So if n is odd, then there's sort of a middle term. This is a great trick, by the way. If you've never seen this before, if n is odd, just write down n is 2m plus 1 for some m. Then t, so I'm going to replace this now and talk about m instead. What do I want here? Tm, 2m minus 1. There's a term in the middle that's tm squared, I think. Do I mean that? Oh, I'm suddenly scared. What do I mean? Oh, I don't want to talk about this at all. I want to talk about T2n. Forget all of this. This is an expression for Tn. I want an expression for T2n. The question's asking me about T2n in terms of... I want to write down the one with the big number, because the one with the big number is then going to be expressed in terms of the one with the small number. Okay, so I'm going to write out my thing here. So T2n is equal to T... Here we go. 4m plus 2. Yeah, this looks pretty good. Do I like this? I think I like this. Yeah, I like this. I'm not even sure I need this m idea. Let's have a go. So this is T4m plus 1 T1 plus T4m T2 plus T4m minus 1 T3 plus dot 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 plus, there's a middle term. Here we go. There's a middle term T2m plus 1, which is Tn. I really regret all these. and all these m's instead of n's. But never mind, I've started now, so I'll finish. And then the next half of the terms are just a repeat of the previous half of the terms, written the other way around. But you know, products are commutatives, so flipping it round again. Okay, so that gives you an even thing over here. So we can say if Tn is odd, then Tn squared is odd, so T2n is odd. And similarly, you can say if T2n is odd. Cool. It turns out I didn't need to do this trick about writing n as 2n plus 1. I didn't need it. I could just have written n's all the way through. Never mind. It's on the board now. Cool. Right. Yeah, see if there's a middle term. Do I need that middle term? Maybe I don't need that middle term. Maybe the middle term idea was a bit of a red herring. Because I get this factor of 2. Factor of 2 makes sure I get a middle term. Yeah, factor of 2 helps out. Okay. Yeah, there's a complicated thing going on that we're asked about whether the values are odd, and I'm also sort of thinking about whether the subscript is even or odd. And 2n is always even. Even if n is odd or not odd. Right, okay, 2n. Oh, that was mind-bending. Like, whether the subscript's even or not matters a little bit for whether you get the multiple thing. Right, useful question. How do we explain or prove there's a middle term? Well, I suppose I've explicitly worked out what it is. That here T2n involves the term TN. I might write down, if I was being really careful and really wanted to make a point of that, I would write down ... in the middle of my writing. I would write down, just to show, like, here are the terms around it to be extra convincing. Maybe if I've written it like this, I might write it the other way around to be even more convincing, but you know, to say, look, here's the middle term, I found it, it's Tn squared. The subscripts add up to 2n. If I had to explain it in a sentence, I think it's kind of clear enough that there's a middle term if things are even. Okay, cool. Where did that 4m plus 2 come from? Yeah, well, I wrote... It's a good question. Look, this is why doing them live makes it more confusing, right? Because I decided to write n is equal to 2n plus 1, because it's odd. And then I plugged it in, so 2n is equal to 4n plus 2. And then I regretted that, but it was too late. So, sorry. I didn't need to bring an m in here at all. When are the solutions going to be posted for 2021? Let's talk videos. Solutions are going to be posted the day after the MAT. The rule on the MAT is people take it in different time zones. Please don't discuss the MAT questions online until 24 hours after the test, because people in other time zones might still be doing the test. So it's under embargo. We can't talk about it online for 24 hours after that. I think that includes don't message people about the MATs for 24 hours until after the MAT. The day after the MAT, we're going to post the solutions doc and a 10-minute video doing MAT 2021 in 10 minutes or less. You might have seen last year's MAT 2020 in 10 minutes or less. It's me trying to speedrun the video, trying to speedrun stuff. Separately, we've made these long 2-hour videos looking at all of the questions in more detail. I'll put a link on the MAT Live page for those ones that we've already made. They exist up to 2019. We're going to do a 2021 as well at some point in time for the live stream in a couple of weeks on the 2020 paper. Haven't done it yet. Need to find 2.5 hours to record that. Sometimes more. Oh well. Yeah, how do we go from Tn squared to T2n? Yeah, it's a good point. I guess I've got T2n on the left here. This is my expression for T2n. Maybe I'll write out a different line. Seems to be annoying people a little bit. I'm going to write it out without the m's. I've realised that the n's were distracting and not m's were distracting and not very helpful. So this is my formula for how T2n depends on the previous values. There are lots of terms here. There are some terms in the middle. These numbers are getting bigger. This one's really interesting to me because it involves Tn, which is a thing in the question, and involves squared, which is just, oh, it's lovely. This equation is very wide, indeed. Okay, when I do that, so I've written out my equation, I'm thinking, you know, that the n in here is kind of different from the n in here, because on the left I've got tn here, and here I've got t2n, but I'm following a rule, right? That you write out all of the previous things and backwards, and you add them together. So this is kind of what the dots are doing a lot of work here. It's kind of what this expression means. Okay, good. So I've written all that out, and then I noticed that most of these terms are repeated. They're written the other way around, but they're repeated, except for this one. This one's separate. This is tn squared plus, so it's 2 times a whole bunch of stuff plus tn squared. And that's really good, because now I can talk about t2n, even or odd. This junk in here is multiplied by 2, so it's even, if you take the 2 into account as well. Even all of this together, and tn squared. So I can talk about even and oddness without having to worry too much about all the junk inside the brackets. And that lets me relate t2n to tn. Okay, we didn't need to write n is 2n plus 1 at all. It was silly of me, really. And the worst thing was, as I did it, I felt really clever, and I made a big point of, look how I zoomed in, look how clever this is. And we didn't need to do it at all, yeah. Cool. Molly's not going to watch the video because, yeah, I know the 10-minute video is not for everyone. Some people come out of the exam and they really want to talk about the questions, and they really want to see the answers really quickly, and it's helpful for them, I think, to have some official quick look at the solutions really quickly. I wasn't that sort of person. I never wanted to talk about exams after the exam. So if I were you, I wouldn't watch the 10-minute video, which feels weird me saying that because I'm going to go and make the 10-minute video. What am I doing? Cool. I'm doing maths. Let's vote on another one. Have I made the mat yet, says Adam. Yes. I liked the bit earlier, somebody said, have I seen the mat? I was like, yes, I saw the mat when I was writing it. Let's quickly remove question 5. Let's do another one. I'm still here. Some people are still here. Who's still here? Some people are still here. Cool. I can't remember what was winning next. Oh, is it 1B? Oh, is it 1B? 1B is now winning. Oh, and somebody's put 1B 4 exclamation marks in chat. Thank you, anonymous person. How do we see our score on the mat after sitting it? If you've applied to Oxford, then you'll get an automatic email in January. So at the end of the Oxford admissions process, you get an automatic email with your mat score. We put lots of new line in. So the email says near the top, this email has got your mat score in. Don't scroll down if you don't want to see your mat score, so you can delete the email if you don't want to see your mat score. And then further down it says your mat score is blah. So you get your score automatically in January if you've applied to Oxford. Chat's great. Thank you, chat. I won't spend too much time talking about it, but you have voted for it. Yeah, okay. X plus I1 really wants Q1E, which I think I can do quickly-ish. Have I already made the 10-minute video? Not yet. Can I leak the paper? It says people want me to leak the paper, which is very that person, that Rickroll, really good. Yeah, cool. Somebody says thanks, and they put their username as 2018, which is nice. Best advice is on sitting the mat this year. I think it's going to be. I think it's going to be explain your answers. Write down those small words that help explain what you're thinking for the question, so that when you lay out your working, people marking it can see what you meant. That's for the long questions. And also, I say that every year. Right, cool. Smile if recursion is on the 2021 paper, which I have to... Why are people trying to get me to leak stuff? Okay. Worried. Okay, cool. Right, good. 1B has actually won this vote, which is nice. We're going to talk about 1B really quickly, and then I am going to talk about 1E, I think, maybe. What do I think? Do I think the MAT 2020 paper was easier than normal? Yeah, I think the average score is a bit higher. I think I agree with that. 1B is based on my research. Ooh, thanks for voting for it, everyone. So 1B is based on a problem that I had to solve in my PhD. It's secretly fluid dynamics. But the question doesn't involve any fluid dynamics, of course. The question wants you to know, does y equals e to the kx satisfy this equation? And the equation's hideous. It's like, technically, it's some sort of second order nonlinear differential equation, but don't think about that, because we don't know anything about second order nonlinear differential equations. What we do know is we know about differentiating e to the kx. That's the thing that I'm trying to test with this question. That's the thing I'm trying to check. Do you know how to differentiate e to the kx? Can you work out the second derivative? Because maybe you'd be trying to find turning points of e to the kx. I mean, it doesn't have any, but you could do the second derivative, right? Okay, it turns out that people really don't like doing derivatives of e to the kx. People found this question really quite hard. Sorry if you're watching from, if I made you do this test years ago and you're now watching back, then you're probably thinking, oh, goodness me, right, okay. This fact is on the syllabus, and then this fact is a sort of combination of, you can differentiate it again, right? Because there's now a constant multiplied by a function that you know how to differentiate. So you get this, okay. So that's the first kind of key idea. You know what these things are. The differential equation really is this. Well, okay, the differential equation for these functions, where k is some number, does this. Right, what's the order of dx? It's k e to the kx minus e to the kx equals, and then this side is e to the kx, k e to the kx. Okay. I did think really carefully. That's right. Cool. Good. Yeah, I agree with this statement, James. I don't think anyone wants to watch this back after exams are done. Not kidding myself. Cool. Right. Yeah. No, I'm well aware. After maths over, any sort of following that this channel's got. I've seen the stats from last year. Any sort of following that this channel gets from day after the mat. Oof, goodbye. Have a nice day. Okay, we can divide through by e to the 2x. Both sides are multiples of e to the 2x, e to the 2kx, I suppose. Which is nice. There's an e to the kx in here, there's an e to the kx in here, and there's two multiples on the right. So now we've got a cubic equation. And the other thing I learned from looking at people's solutions to this is that people really don't like working out how many solutions this cubic might have. I think because people divide it by 0. If you don't divide by 0, then it's not so bad, right? If you keep track of the fact that 0 could be a solution to this cubic, then you could do this. There's a bit of difference of two squares, because I love difference of two squares. There's two solutions here, and this third one. I think it's exactly 3 different solutions of different values of k. Why not just switch e to the kx to a y so that it's easier to write? Yeah, I see what you mean. So I could have written ky over here and k squared y over here. I considered it. I think that looks a little bit mysterious. Writing it out like this makes it more obvious what I was doing. I don't know. It's true. You're allowed to do it. Makes it easier to do the working out, I suppose. What is this channel after math? So something, which is quite nice. After math, this channel is going to go back to the Oxford Online Maths Club. So if you scroll back to what we were doing before maths, we're going to do the Oxford Online Maths Club again, which is fun and super curricular, extra bits and pieces of mathematics. There's extra bits and pieces, not math questions, just other bits of fun maths. Hopefully helping to prepare people for maths at university, or if we pick up any new year 12s, then showing them that maths is really cool and fun. Cool. Some people are coming back for OOMC. Some people are here from OOMC, Oxford Online Maths Club. Oh, hang on, this one feels important today. Let's answer this question today. Is it a disadvantage to submit your application closer to the deadline, or rather is it better to send your application in early? For Oxford, it doesn't matter. We get all of the applications from UCAS, we put them all into our databases and our systems, and tutors can't see any of them yet. We get everything together, we get everything sorted, and then we let tutors see it all together. So the tutors considering your application don't know when you put it in. They don't know if it was 2 minutes before the deadline or a week before the deadline. They don't know. I think other universities might do stuff live, and while applications are coming in, it's very complicated. For Oxford, we've got a process with a timeline. So actually doesn't matter. Although, please don't miss the deadline. Cool. Smile if maths is on. Oh, this is like the new thing. Like, right? Okay. Good. This question about multiple choices has come in. Sorry. If you get the question correct, but the examiner can see your method is wrong, but you got it correct, you're going to get the marks. Would you get the mark? Would also disregard? No, you get the marks. You get the marks. If we look through your paper and we look at your working out, then we'll be able to see your working out. It's going to be quite hard to notice that you were lucky and wrong. That's going to be pretty hard to spot. I'm going to do 1E just because one person asked for it. The idea for 1E is that the circle is centered on the origin, and it includes some a whole number of points. The question is quite mysterious because it says let n, but n is actually just a number. N is just the number of points that are inside this circle, or on the circle. It's radius 2, so there are points out here. So I think this is kind of the problem with understanding the question to start off with, is that it's written in this really mysterious way. This point is not inside the circle because it's too far away from the origin. Neither is that one, and symmetrically. The question is kind of quite weird, but n is just 13. It's a little bit unusual that there's a variable in the question that is just 13. So then when you read the next bit of the question, this bit, what's the smallest amount the radius needs to increase by? So I want to make the circle bigger so that there are, that's not really, it's 2n minus 5, it's just 21 grid points inside the circle. So it's got this kind of weird element going on that it looks like you've got to do this big general thing involving n, but actually n is just the number 13. So I just need to make it big enough that these points are not in the circle yet. I need an extra, what is that, an extra 7, 8 points. And oh, in my picture, there are 8 points that are pretty close to being in the circle. These 8 points, they're not inside the circle of radius 2, but if I make the radius just a bit bigger, then those points will be inside the circle as well. And the smallest I can increase the radius by to get those inside or on the circle is if I make the radius just big enough to get this point here. That point is distant root 5 from the origin. So then the other weird thing is the question wants you to talk about how much to increase the radius by, which is root 5 minus 2. Because it started at 2 and you're increasing it to root 5. So it's got kind of weird bits and pieces going on in the question. But the actual idea of, I just want to make the circle bigger to get more points in it. Just a bit bigger. Yeah, they're in the circle now. Just a little bit. Cool. Cool. And we're getting spammed again, which is good. Cool. 1E. This is a good question. I like this. What are the examiners looking for when giving partial marks on the long questions? Working out. Having the right ideas, the right kind of method, or something that would work to get you towards the answer, but maybe you haven't quite finished getting there, or maybe you get something else wrong and then it kind of goes wrong from there. But maybe you've had the right ideas. It's kind of the best bit about getting humans to mark it, is that humans are quite good at spotting your intention, or that you had the right kind of human idea about what to do on a question. Maybe it didn't work out, but you should get some credit for having the right idea. Cool. Oh yeah, I got root 5 by Pythagoras. It's 2 along and it's 1 up. Cool, yeah, not a dumb question. It's not that bad. Cool, right, let's do the vote again. How are we doing? It's 20 past 6. We're doing quite fast actually, but doing quite fast. It's one of those days, isn't it? We're doing quite fast. We talked about 1B, talked about 1E. Cool. Oh, got 6 is doing well. Okay, I'm getting spammed. Warwick, my understanding is that their offer text involves lots of different exams, like MAT and STEP. I think that if you don't get a reduced offer based on MAT, then there's a possibility that you can reduce the offer with STEP, or that the offer text can include STEP, or have this option in it to somehow use STEP. It really depends what offer they make you, if they make you an offer. I think it's possible. I think it's possible to do MAT and STEP. They're at completely different times and they're completely different tests. I think it's possible to do MAT and STEP. I don't know how Warwick copes if you do both, but I think they've worded it so that if you do one or the other to a certain standard, then you meet part of the offer. I can't remember how their offer text works. You should really ask Warwick. Sorry. Smile if there's a trick question. Let's do more short questions. Yeah, can we do more short questions? People want to do question 6. I kind of get F on the screen as well, so I might do F. Bath said they'll look at your math score. Cool, okay. Good. I've been talking to Bath about how they're going to get access to math scores as well, so that's all nice to know. That's all linked up. Good. Okay, question 6 is 1. I can see F and G there as well, so I'm going to really quickly talk about F and G. Cool. Right. The Rickroll is the top voted thing in the chat today, which is nice. And I saw also they said that it got 43 clicks, which is almost all of us. So well done, everyone. Okay, right. Steadily losing viewers, possibly because of time or possibly because of content. Who can tell? So this is about a particle moving in the xy plane. It can move either. It sort of does knight's moves from chess. But maybe that's not a helpful thing to say. Who knows about chess? Some people know about chess. Okay, so it can start at 0, 0, and it can move, translated by the vector 2, 1, which would take it over here. Or it could be translated by the vector 1, 2. No, sorry, the first one I drew was 1, 2, wasn't it? And this is going to be 2, 1. There we go. How do vectors work? The first number means, okay, 2, 1. This one's 1, 2. Okay. And then it can do that again. It takes turns. So it's going to do something like that again. So it could do a 1, 2 move again and get up to 2, 4. Or it could do a 1, 2 move and then 2, 1 move and be somewhere over here. Or it could do some combination of those, which I think takes it to the same place over here, or it could go over here. And there's lots of possibilities for how it moves turn after turn. Okay. Look, is it possible to do all of Matt, Step and Tamura to collect all of the Infinity Stones? Yes, Matt and Tamura are on the same day though, so if you do Matt and Tamura, then I think you do one, you quarantine in between exams in the exam sense, not the COVID sense, and then you do the other test, so it's quite a lot of work. Okay, 14. So the thing you're supposed to notice for this question, I'm going to go and do question 6 in a moment. The thing you're supposed to notice for this is that all of these possibilities are contained inside. There's some sort of extreme choices you can make. The extreme choices are that you always pick this vector to go, what is that, 1, 2 lots of times. Or you always pick the 2, 1 vector. You go over here. If you pick some combination, you end up in between those two lines. Those lines are the lines y equals x over 2. And this is the line y equals 2x, just to be precise about what those lines are. So I guess the key observation is the point 2575 is not inside the kind of triangle of places you can get to. So you can't actually get to the point 2575. It's too high up. 75 is 3 times 25. So this point is kind of too high up. We've got, even if we go 1, 2, 1, 2, 1, 2, even if we go 1, 2, 1, 2, 1, 2, this is me moving along the line 1, 2, 1, 2, 1, 2. Even if we go along that, we'll go through, so 1, 2, so we're going to go every x value, we're going to go up 2, staircasing up, 1, 2, 1, 2, 1, 2. Even if we do that, we're not going to get to the point 2575. It's up here. So we've got to do a little bit of geometry to work out what's the closest point with whole number coordinates on this line. Which one's the closest to 2575? Okay, I think candidates for this point, what I'm going to do is I'm going to try and find a point on this line. Find a point on this line that's like a, so this is dropping a perpendicular, with this kind of geometry idea that I should drop a right angle down. Oh, Matt and Tamura are on different days this year. Okay, disregard the previous thing I said. Look at the websites. Maybe Matt and Tamura are on the different dates. Cool. Okay. I'm gonna look at perpendicular lines. Maybe, if I'm lucky, that point there will have whole number coordinates, and I'll be able to stop thinking. If not, then I'll have to think about how, it's taking turns. So it's going to go work there and then skip over there, and I'll have to think about maybe a couple of points to find out which one's closest. I hope that doesn't happen. Okay, right. Let's find this line here. A lot of lines in this now, aren't there? So I'm moving along this line y equals 2x. This line is going to be y is minus 1/2 x plus it's perpendicular to 2x, so it's got this gradient. And I want it to be, what do I want to add here? Minus 12.5. I want to add, is this right? Seems a bit wrong. I want to add on 87.5. That doesn't seem right at all. Never mind. Well, that goes through the point. 25.75. Pause to think about what I've done. Yeah, I like that. Believe it or not. Okay, so where does that meet y equals 2x? Well, that means y equals 2x at 2.5x is equal to 87.5. It's a bit weird algebra, isn't it? What does that make x? Oh, I've got to do some division. I did not come here to do division. Are we brute forcing this? Oh yeah, third and fourth. Okay, check the website, everyone. If you just joined the live stream, I'm about to try and divide 87.5 by 2.5, and I'm not looking forward to it. Having done the first part of this question quite quickly, I'm now going to make a real mess of this part. How do I actually want to do this? I'm sort of concerned. 160, 175 over 5? Yeah. Is this stupid? 37? 39? I feel like I'm going very wrong. What do other people think? Help me out, chat. I've embarked on a question and I've lost confidence entirely. What am I doing? 25.75, so minus 1/2 x, minus 12.5, added onto the 87.5 is 75. So I've got my line correct, and I need to intersect it with that. I think I'm doing good work. I'm not convinced I've divided these numbers correctly. 175 over 5 is 35. It's the division that's getting me at the end. 175 over 5. Oh, people are helping. 35. Carl Frederick Gauss has risen from the grave, turned up in chat, and said 35. Never. Thank you. Cheers. Cool. Maybe it'd be easier to work out if I wrote over 2 instead of and a half. Yeah. Okay. Criticism of my maths as well. Good. Somebody else has used perpendicular vectors. Fine, if you know loads of vector stuff, maybe you can do it like that. 35, cool. What was that? Oh, that's the point here. Oh, brilliant. It's got a whole number coordinate. It's 35, 70. That looks pretty close. I'm going to use some quick Pythagoras to work out how close that is. That is the square root of 10 squared plus, and it's 5 squares difference away in the y coordinates, which is the square root of, don't stop me now, chat, I'm doing really well now. 125 is now 5 root 5, which should be, oh good. Phew, we got there. It's always the simple ones, isn't it? I was doing so well on writing down my lines and intersecting them, and I was feeling pretty clever, and then, oh my word, I've got to do this division. Terrible. Yeah, maybe I do need some sleep. Cool. Do the stats on the average mark on the Oxford website, they only include Oxford applicants. I don't include non-Oxford people in those stats. Sort of doesn't feel fair. They didn't apply to Oxford, so it's sort of almost a little bit like talking about them on the website without their, well, you know, it's statistics, isn't it? But almost a bit like talking about them on the Oxford website feels weird because they didn't apply to Oxford, so I restrict it down to just the Oxford applicants. We got there, yeah. Somebody says congrats XD. There we go. Round of applause for me, thank you. Good. Am I going to do one more? I'm going to do question 6 in a moment. How are we doing for time? We're doing all right for time. Okay, we're going to do question 6, and maybe I'm going to get some sleep. But first, question 1G. I really like question 1G. It did all right in the poll just now. I'm now freestyling as well. I'm ignoring the poll. We've got some parabolas. One of them looks like this. Y is plus or minus root x. It's kind of a sideways parabola. And we've got this parabola, y is x squared plus c. So that kind of plus c moves it up and down. And we're told to pick the value of c just so that this parks boop, on top of the other parabola. So that it's just touching at a single point in here somewhere where they meet and they have the same the same tangent. So they must have the same gradient there. And I suppose the same value at some point. We don't know where. Okay. Cool. We got a special request in chat for a computer science specific live stream, which actually did happen last week. People don't seem to have noticed that it happened last week. The recursion one was CS specific. We had a CS guest. We talked about CS questions. That was computer science. Cool. It's actually quite fun doing this algebra. It doesn't work in the way that I expected it to. I want the value means that I want x squared plus c equals square root of x. That equation is really horrible. So like the equation for the value is pretty mad, but then the equation for matching up the derivatives is pretty nice. So this is y equals square root of x. The equation for matching up the derivatives is lovely. That's how we all feel. So you can use this one to find out what's the value of x first, and then plug it back in to find the value of c into. So do this one first to solve this for x. So this works out to be like x to the 3 over 2 is 1 over 4. So x is 4 to the minus 2 over 3 or something mad. And then you plug that in up here, and it just sort of works out. 4 to the minus 4 over 3 plus c is 4 to the minus 1 over 3, which is, I think, the same thing as saying c is this 1 minus 1 over 4. So 3/4, 4 to the minus 1/3. Might have mixed up my powers of 3 and 4 somewhere. A little bit of regret. No, the regret's gone away. This is going to be 3 over 4 cube root 4, which is b. But it's this idea that actually the derivative one is nicer than the matching up the values. Cool. Okay. How do you solve problems on graph plotting where the functions of the form f of x times g of x times d of x? I would work out values of those functions, think about where any of them is 0, because if one of them is 0, that product is 0, and I think about whether it's positive or negative. Any other special values? I'll go for it. Never seen that before. Cool. Yeah, definitely discount negative values just from the picture. We want a positive value of c. It's going to be around here somewhere. Positive value of c. And I'm going to discount the bottom half of the graph as well. Somewhere in here I just started writing root x for looking at the top bit of the graph. So discount all the negative stuff. Are there negative options? Oh yeah, just c. That's positive. One of those days. Right, cool. That was quick. I think I got the answer right as well. It's question 6 time. People who want to computer science stuff, welcome to the live stream. This question is about Egyptian fractions, but we're calling them friendly form. Whenever I've seen them before, they've been called Egyptian fractions, but here, friendly form for numbers written as a finite sum of distinct reciprocals of positive integers. Okay, and we're given an example, which is nice. Part 1 is fine, just write out these numbers using fractions. Bit of trial and error if you like, off you go. Part 2 I find really difficult. So part 2 is to talk about, if you do this and you start with the number q, some fraction, and you choose m to be the smallest natural number such that 1 over m is smaller than q or equal to q, then some stuff happens. The next fraction down, when you take that off, so you're being greedy, you're taking off the kind of the biggest fraction that you can by using the smallest value of m you can. You take off the biggest fraction you can, being greedy, the next thing down has a smaller value in the numerator of the fraction, if you write it in lowest terms. Okay. Do you want some resources on how to solve problems of graph plotting with a function in the form f, g, t? I would do the same thing that you do for f times g, but I would treat g times t as a different function. So all the resources you know about sketching functions, all of them apply. It's just some complicated function. Write out the function, forget about f, g and t, write out the function, off you go. Or if you're doing some sort of general thing, then I guess that's impossible. Yeah, classic. While doing part 2, I managed to come up with a way to prove that it's false. Dangerous. Right, okay. Here's the kind of key idea. M is the smallest natural number such that I retyped the questions for this. I think. Maybe that typo was in the paper. Interesting. Okay, 1 over m less than or equal to... I didn't retype that. Is that typo in the question? Huh. welcome back to the MAT Livestream, where we're discovering typos from 3 years ago live. This thing has got to be less than 1 over m minus 1. The previous value was 2... what am I doing? I've got really distracted by that T. The smallest, m is the smallest number that does this. So the previous value, m minus 1, that's too small. That must be on the other side. Q over here like this. This form is actually slightly more useful to say that q is less than 1 over m minus 1. That's actually important because lots of numbers do the thing on the left. If you make m bigger, then this stays true, but the thing on the right is kind of interesting because it's only true for some values of m. And the special thing about this value of m, I suppose, is that it does both, but it turns out that one on the right is a little bit more interesting. If q is equal to a over b, then we can write this thing on the right as a over b is less than m minus 1, which you can sort of rearrange to say this, am minus a is less than b, which looks quite nice. The thing on the left just tells you that am is bigger than b, which is okay, I suppose. But yeah, you got this kind of nice thing about subtracting an a here, and things ends up being less than b. Anyway, what am I doing with this? Well, we're told that q is a over b, and that we're interested in q minus 1 over m, which is a over b minus 1 over m, which is am minus b over mb. The reason I pulled that all together is because, well, partly because I wanted to do anything I could with it, and partly because I wanted to build it into one fraction, because we're told this is equal to c over d in lowest terms. So the question is, in lowest terms means, well, maybe this fraction I've got out is in lowest terms, or maybe not. This thing is exactly equal, right? That q minus 1 over m is equal to this fraction. I actually know that already this thing on the top, this thing here on the top, is less than a by this inequality that we were messing around with before. So this thing's already smaller than a, so that even if I write this now in lowest terms, even if there's some common factor in the top and bottom here, it only gets lower. So I know that c is less than am minus b because lowest terms. C is, you could write this fraction using huge numbers, but c is lowest terms. That's the special thing about c. That means that c is less than this particular way of writing the fraction, and I know that that's less than a. So c is less than a. Okay. George has put some maths in chat. M is less than a of b. So is that true? If you're bigger than that, are you smaller than the reciprocal? I'm not sure. Oh, m is big, and m is a whole number and it's big. So m is less than the reciprocal? I think the reciprocal might be somewhere between 0 and 1, so I'm a bit suspicious of that first bit, George. I'm not sure I get the first bit. Cool, okay. Okay, right, let's overview the next couple of bits. This is the hard bit of the question, by the way. The rest is not so bad. Because now we've got this idea of, if you're greedy and you do this thing, you subtract 1 over m, you write down 1 over m, the smallest number m, the biggest fraction 1 over m that you can. Take away the biggest fraction you can. When you do that, you get back a fraction, c over d, that has a smaller numerator. It's smaller for two reasons. One, because you could write it as am minus b over mb. That's a smaller number on top. Secondly, it gets smaller because you can cancel fractions to make the numbers smaller on top and bottom. That means that every time you do this, if you now repeat this on c over d, so a little bit of a process here to work on the number q, so write down 1 over m, the biggest fraction we can, and the leftover bit, repeat the process on that. As we do that, the leftover bit each time has a smaller numerator each time, So whatever number it started at, each time we do this, the numerator gets smaller. It's a whole number getting smaller. It's going to hit 1 at some point. When it hits 1, the leftover bit is itself a 1 over fraction. There's a little bit to check that it gives you distinct reciprocals, that you don't get the same number twice. That's because when you subtract the biggest possible fraction, that is actually genuinely quite large. It's bigger than half the number. I think, yeah, bigger than half the number. So you're actually making progress each time you do this. Okay, actually working it out by doing some sort of, this is called a greedy algorithm, computer science people, greedy algorithm, because you're taking off the biggest bites you can each time. It's very greedy, so apply that to 4 over 13. And then this last part is just to check that for other numbers, you can do something similar by greedily writing down as many of these fractions, taking off 1, 1 over 2, 1 over 3, 1 over 4, taking off as many as you can, and that'll get you up to, eventually that sum, because that sum increases without bound, eventually that sum will go past the positive rational number you're looking for. So, don't overdo it, don't get too greedy. Stop when you've taken the fractions from the start of the sum. Stop when it's about to be too big, and now you've got a leftover bit that's somewhere between 0 and 1. In particular, it's smaller than the next fraction that you were about to add on, because if it was bigger, then you would greedily take the next fraction too and keep going a bit. So you get down to some leftover bit that's smaller than the next fraction. At that point, use the previous algorithm to write it in terms of small, in friendly form, using smaller fractions. So this is the idea that we're being greedy all the way through, writing down the biggest fraction we can, and mostly the question is about proving that greedy process actually stops. Okay. Someone says Ali says it's like Dijkstra's algorithm. I can't remember how Dijkstra's algorithm works, so good luck, computer science people. Let's go. Would like suggestions for question 4, which is often about geometry or something like that, right? It's actually quite limited in terms of, there are books about geometry. They're not very helpful for math geometry questions, because math geometry questions often only use very basic ideas from geometry about how big triangles are or how big the area of a circle is. There's this exercise that I made people do in Oxford Online Maths Club at one point, to work out if you have a circle that's sliced by some line like this, and I tell you the angle here. Can you work out this area? Now, of course you can, because you know how big triangles are and you know how big circles are, but it's worth doing stuff like that, because I can see lots of shapes like that in this question. Like there's one here, which is like exactly the area we're not asked for, and there's a bigger one I can see where the small circle is also chopped up by a circle chopped by a line. So remember, the difference between those two would be the shaded area that I want. If you do practice problems by sort of on the geometry sheet of the MAT Livestream, link in the description and at the bottom of the screen, there's warm-up questions like this to practice doing calculations like that. I put this one on the warm-up sheet for the geometry sheet because I was thinking about this question. Okay. What's the average mark going to be? I have no idea. Cool, good. Okay. We got 10 minutes until 7 o'clock. There's not no one here. I'm gonna turn the poll back on just to see what happens. What have I talked about? I've realised it's slightly annoying that I'm deleting options as we go through and talk about them, which is, I'm gonna have to put them all back for next week. If I delete all the ones we talked about, then I think 4 is actually doing all right. People who are currently watching are forced to vote against whatever people were voting about before. So if people voted and then left, and their votes survive. So if you're actually watching live and you have a particular preference, maybe also let me know in chat. 7 and 1J. Have we got a computer? Is it just computer scientists who have hung around for the last bit? Let's do 1J. I'll talk about 1J and wait for question 7 to overtake. 1J is fun. So 1J is fun. So you're asked to think about these curves for all polynomials p, right? We're asked about could it be this for some polynomial p. So maybe if p is 3x squared minus x, then this says 3x squared minus x plus 3y squared minus y equals 0. That curve, to sketch that curve is pretty hard, and we're asking you to think about that for all possible polynomials. It's kind of mad. There's an idea though that if xy works, then yx also works. That's a kind of powerful idea, that if you swap the numbers x and y around, well, they're treated symmetrically. So if you swap x and y around, then you'll get a different point that also works. Someone in chat live also says they actually liked question 4. Do you want a fresh poll? Maybe we should reset the poll, see what happens. I'm kind of a bit embarrassed. If I reset the poll and then nobody votes in the poll, it's kind of recorded forever that I did a live stream with very few people in it, but hey. Anyway, people watch the replays, so it's not pointless. I will reset the poll in a while, I think. Okay, cool. I'm still having fun. Okay, so it's got this symmetry. That rules out A. I think not A, because that doesn't have the right symmetry, right? Here it's showing the point 1, 0 works, or A 0 for some A, but it doesn't have the point 0 A. Okay. Awkwardly, that gives away the answer, I think, because if it's not A, then that rules out 4 of the options. By process of elimination, the answer is then C. So this turns out to be a really good idea that lets you do the questions straight away. Otherwise, you've got to have more ideas, I think. Let's try and make some more curves. This one's got quite sharp corners, or maybe they're sharp corners. It's a bit hard to tell, isn't it? I suppose it's a bit surprising that we can't do this one. Maybe because it does have the right symmetry. These 3 all have the same symmetry, so I'm kind of thinking B, C, and D, but not A. That's not one of the options. In fact, it turns out that you can't make B using any polynomial. Here's why. Along this edge, you would have to have the same value for all the different values of y that you put in. So the polynomial would have to, you're keeping the same value of x, but you're changing y. And as you do that, you're putting different inputs in. The polynomial would have to be polynomial constant. What is your polynomial doing? Is it constant over here? What is this? For that to work out. So that's a little bit odd. It can't really do that. Maybe that's not convincing though, because how do you know that's actually a straight line? I'm not sure you do know that's a straight line. So there's a question about like sharp corners. Can you do sharp corners? How do you know that's actually a sharp corner? I think it's a little bit tricky. I speed up the fewer people are here. Oh, Carl Frederick Kaus is still here. Hi. Is D just x plus y equals 0? So it's included? Yes, that's true. This is just the line x plus y equals 0, which is true with like the polynomial x. So yeah, that is allowed. Cool. Which rules out 3 of the options. So good work, Gauss. Rilo's off. Bye, Rilo. Oh no, Rilo's here. Rilo's here next week. And now. It's very confusing. I don't know if B's here, Riley. But cool. Maybe B watched the replay, who knows. So we can make this one. Gauss told us how to make this one. This one looks like a circle. I think someone just told me that the equation I've written down is a circle, which is a bit surprising. I don't know where the circle is, but this circle looks to me like x squared plus y squared equals 1, which is awkwardly not quite the form that I want, right? But you can rewrite this. This is slightly awkward, but you can rewrite this because I want an equals 0 on the right, and I want these brackets to be the same kind of polynomial. So now here with my polynomial cunningly chosen to be x squared minus a half, I can get something that looks like this circle. So that's pretty good. Yeah, let's go. I thought the same thing to start off with. It's not x squared plus y squared equals 0. It's x squared plus y squared equals r squared. And then we've got to get rid of the r squared by moving it onto the left somehow. But we can do that with the power of subtraction. Cool, live stream's getting weird. Oh, right, okay. You've asked this question 3 times. Let me have a quick look at it. Approve, reject, reject. I'm well, thanks. How do you let other unis know about your MAT score? Oh, I actually really want to know. Okay, if you've applied to Imperial or Warwick, then they will automatically get your MAT score. Provided when you registered, if you tick the box for Imperial or Warwick, or the people registering, you tick the box, then they automatically get your MAT score. You don't have to do anything. If you would like another university, I'm thinking of Imperial, Warwick, Bath and Durham. I've named Imperial and Warwick again, just in case if you didn't tick the box, or you decide later to share your MAT score with Imperial or Warwick, or you're thinking about Durham and Bath, they get sent an encrypted spreadsheet that's got scores in. It's encrypted so that they can't read your score, and they don't know who you are, and they don't know anything about you. But if you give them your MAT registration number, which is it's a 5-digit number that you write on the front of the test, and it's your number for registering for the MAT. It starts M, so it's M 5 digits. If you give Bath or Durham that MAT registration number, then they can look you up. They can look up your MAT score. You can do that to give them permission to look at your MAT score. Bath and Durham are going to have some sort of process for collecting those numbers from you, so that you can give your MAT scores to Bath and Durham. Cool. I think Flora might have gone. Somebody's asking if Flora's still here. I think Flora might have had to go. When I was finding students to have out, I said that this would be 1 hour, and it's now very much a 2-hour thing, isn't it? Okay, cool. I think I'm going to wrap up because it's almost 7 o'clock. Thanks for watching. We've got polynomials to build C and D. I'm a little bit thinking about how we can make B. Maybe we can't make B. Maybe we can make something that looks like B. It's a little bit complicated. Could we make something that looks like B but gets around this by having slightly curved edges? Slightly curved edges. You can't see it in the picture, but maybe we could do something with slightly curved edges. It's not obvious to me that you can't do B. Luckily, the way the multiple choice question works, once you've worked out that you can't do A and you can do B, can do D, then you eliminate all the options except C. So we're done. Good. Okay, not too bad. Okay, right, I'm going to wrap up there. If you want to watch the other questions, including what have we not talked about, first half of the multiple choice, let's put them on the screen so that people can think about other questions that we didn't talk about today. Integration and parabolas and moving a parabola around. A lot of parabolas on 2018, aren't there? Lots of parabolas. We skipped this question with parabolas as well. I think there might be 5 different questions with parabolas in the short questions. We didn't talk about this question, which is also built of parabolas, or really the geometry question. Well, I showed you the idea for the geometry question. And we didn't talk about question 7, moving around and scoring points by picking up coins. If you'd like to see the solutions, there's a solutions video on this channel. It's easy to find, it's called something like MATs 2018. It's 2.5 hours or something of me talking about the other MAT questions. But for the live show, I'm going to call it a day there. And I'll see you next week for MAT 2019, where I wrote more of the questions. It was fun. But it's not about me, it's about you trying MAT questions. I'd advise you to have a go at questions beforehand. But either way, well, good to see you next week for MAT 2019 on the show. I can't remember how I end these. People in chat, there's normally just chatting, right? So normally you have a bit of normally the chat just sort of winds up. People are saying thanks and bye. Cool, right, okay. I'm finished with another story. So I did the phone story at the start. Last week we had all the new first year mathematicians in the building for their induction, where we told them about how the course works and say hello. And I stood up to tell them about joining in with outreach, joining in with telling people about mathematics. It's a little bit meta, right? To tell people about joining in with Maths Club. I saw someone earlier in chat say, if I come to Oxford, can I join in with a Maths Club? We did an advert to the new first years. We stood up and told them about Maths Club stuff. But we also asked, how many of you already knew about the Maths Club or MAT Livestreams out of the new first years? And I think about a half, or maybe more than a half, of the new first years had heard of stuff like this, which is exciting to see. So I guess see some of you in a year's time. So starting the course for that advert in a year's time to come and help out with things like this. Is that meta enough? That was pretty meta. Yeah, I think we got there. That was meta enough. Right. Okay, I'm losing my voice. See you at 5 o'clock next week for MAT 2019. Bye everyone.